but to describe possible relation between different entities, different aspects like domains and process model inside this enterprise model, we have to, it is important and it is good to have a representation of the whole enterprise model in a single formalism. We can build enterprise model in different modeling languages like BPMN. We can take this BPMN notation to model our process model design. We can take OWL ontology to model our domain ontology. We can take EOL to build our the process workflow. The OWL ontology is the W3C candidate recommendation to describe the formal description of the process, and OWL ontologies are widely used to formally represent a specific application domain. That's why in my thesis we propose how to formalize a simple process model in OWL. My contribution in this thesis, at first I analyzed a simple process model, how we can formalize this simple process model in OWL ontology. Then I made the implementation of these formalizations in OWL. The simple process model that we formalize in our thesis work is can be designed in this Mocky process editor. Mocky is a collaborative tool which supports the process expert who has not enough engineering knowledge in process modeling can draw a simple process model using these three simple building blocks, and this Mocky is available in this website mocky.fbk.eu. So to build the simple process model using these three building blocks, which are start point, process and end process, if we take these three building blocks, we can make a simple process model like this, where the process, I have designed this process model which name is process A, and which contains this process B, C, D and E as a sub-process. Whereas this process B is containing another two processes, P and Q as a sub-process. So in this process model, to formalize this process model, we built formalization axioms, and I divided these formalization axioms in two categories. Firstly, in general axioms, and another axioms are for a specific process. In the simple process model that we shown in the previous slide, have the points and processes. The simple process model starts with this start point and end in the end point, and in the middle it has several processes. These processes can be two types, simple processes and complex one, which contain another processes. So the top level concepts in this ontology, we can define two main concepts, that is point and process. And this point and process is totally different. This point, in this formalization, we can make another two sub-concepts of this point concept, that is a start point and end point, and another two sub-concepts for the process, that is atomic process and non-atomic process. And in the previous slide, I already told that the atomic process is a very simple process. It contains no sub-processes, and it doesn't start with start point and don't end with end point. The non-atomic process here has the start point and end point and can contain another processes as a sub-process. So up to this, we make the concepts to formalize the process model, and the concepts are point and the sub-points are start point and point. The atomic process, which have these properties that I already described, and the non-atomic process, which have these properties as sub-process and starts with the start point and ends with end point. Now I will describe the relations to make to take the relation between these two concepts. At first, has sub-process. This relation relates process and process. That means this relation is only between two processes, and the inverse relation of this has subprocess has each subprocess of. Each subprocess of is functional, and it has subprocess is anti-reflexive. That means a process cannot be the subprocess of itself. The relation here starts with and ends with. This starts with relation is between the start point and the non-atomic process, and the ends with relation is between the process and non-atomic process and the end point. And start with and end with are also functional, because in this process model we support only single start point and single end point. The relation has outgoing link relates to the start point, that means from the point and to processes, and also the process to the start point, end point, and also between two processes. That means it's the relation between these three items. And has outgoing link is antisymmetric, because we put this restriction not to reflects the same link come to the previous items. Property chain. The property chain is the composition of relations, and here we put the property chain. It starts with composition which has outgoing link relation, and we make the has subprocess. For example, a non-atomic process starts with a start point, and this non-atomic process, the start point has an outgoing link to the process. That means that process is the subprocess of this non-atomic process. And in the similar way, we make this two property chain, and to compose this property chain, we need out2, because out2 allows us to formalize this property chain. Now I will describe the axioms that we formalize for the process specific that we design in the monkey process editor. These axioms, like we take this simple process model in the monkey process editor, and we can put these axioms like the process A that we define in this process editor cannot be subprocess of any process. Otherwise, if it's happened, then it will be cycled. And the process A is a non-atomic process, because this is a complex process, and we already tell that the complex process is a non-atomic process, which have a start point and end points. So A is a non-atomic process, and B is also a non-atomic process, where the C, D, E, P, and Q are atomic process. Then if we formalize the description of the full process model in description logics, then the process A will be this way. Process A is a non-atomic process, and it contains 4 subprocesses, and it starts with 2 has outgoing link, and 1 outgoing link contains the process B, and then process C, and then endpoint, and another outgoing link exists from D, and then E, and then it finishes in the endpoint. Now, if I design these concepts and relations in the quantity 4, then the view will be like this. The process, concepts, and the relations. And the formal description of the process A, if I model in this quantity 4, then it will be like this. Now I will describe the implementation phase of my thesis work, where at first I take 2 approaches in the implementation phase. Before formalizing this process model, I check this process model whether this process model is valid or whether this process model contains any cycle. Otherwise, we don't go further to formalize this process model. So in this process model checking phase, we make the restriction whether is there any cycle in this process, and whether this process is valid or not. Sometimes if the process designer don't put any start point or don't put any end point, or if the process designer only make any link direct to start point to end point, that is not a valid process, we can check from in this phase before going to formalize this process model.